everyone, my name is Maria Rincon, and this week I'll be presenting you with the same lesson plan that I did last week that involved introducing the concept of simple machines directed to a third grade level classroom, but this time I chose to modify it in order to add the learning modalities that we have been learning in the past couple of weeks. So the learning modalities that I chose to adapt to my lesson were the visual and tactile kinesthetic learning modalities. So in this lesson, I'll be introducing the 6 basic machines with a set of slides that will include the name of the machines, their definition, and their function, with very simple wording to be able for them to understand it better. The slides will also include a lot of visual examples for our visual learners in order for them to comprehend the concept of each simple machine and what they look like. So, for example, my set of slides would be from the wheel and axle, and the wording would say, an axle is a rod that goes through the wheel. This lets the wheel turn. It is easier to move things from one place to another. Examples: cars, roller skates, wagons, and doorknobs, gears. So here is an example of the wheel and axle, naming the parts and an example. Okay, the other one would be the inclined plane. Again, a very large visual example. And the definition: flat surface that is higher on one end. You can use this machine to move an object to a lower or higher place, making work of moving things easier. Examples: ramps, slanted road, slide, path up, and a path up hill. Sorry. The lever, again, visual example, and a lever, it's a board or bar that rests on a turning point, and a fulcrum, the turning point of the lever. Here I place with the naming of the parts. And the examples are a seesaw, hammer, or a crowbar. The pulley make up a wheel and a rope. The rope fits in the groove of the wheel. One part of the rope is attached to the load. And the pull on one side of the pulley, the wheel turns and the load will be moved. Pulleys will let you move loads up or down or sideways. Examples of the pulley are crane, flag poles, and or clotheslines. And here it is, the example of the pulley. The screw. The screw is a simple machine made of another simple machine. It is actually an inclined plane that winds around a nail. Some screws are used to lower and raise things. Others are used to hold things together. Examples are jar lids, light bulbs, stools, clamps, and key rings. And here's an example of the screw, the jar lids, and the light bulbs. And at last is the wedge. Simple machines used to push 2 objects apart. A wedge is made up of 2 inclined planes. These planes meet and form a sharp edge that can split things apart. Examples: nail, fork, knife, and axes. And here's an example of the wedge and how it, turns things apart. Okay. So after this part of the lesson is over, then I will present my students with a set of real-life examples of the machines that are found in their environment, such as jars, so they can see the jar lid and how it screws, it's like a screw machine, and how it holds the tap and the jar together. The wheel, and I would never bring these to a real classroom, but I didn't have any plastic ones, but the knife and the fork can be used as an example of the wedge, but just to keep in mind, use plastic ones, don't take them. But the reason I want this to bring as an example to my students is because this will serve as a tactile and kinesthetic modality, because I want the students to be able to manipulate each example and see where they can find each simple machines in their environment, and see how they make daily activities easier, or how they can find them in anything they use basically, or in their real life. After I introduce the the examples and the definitions of the simple machines, I would introduce my students to the worksheet. I created one, and where I want in the worksheet, I want them to think about a problem where they can use the simple machine to solve it. In this case, I made them to think about how they can move an elephant from one point to another. And in this part, I thought that the teacher can also check for understanding, just ask the students out loud, see if they have comprehended each simple machine to perfection. In case there's any doubts or miscomprehension, the teacher can clarify it out, and then at the time of actually working in the worksheet, there won't be any troubles in solving any doubts. They can actually place their correct knowledge into solving the problem. And the thing is that I placed the whole 6 machines here in the worksheet because I want them to rationalize that not all simple machines are useful in every situation. I want them to, make the understanding that, well, maybe a screw won't help me to move the elephant from one place to another, but I want them to be able to rationalize and so that they can be able to think on their own. So this is why I listed the whole thing, and it's a very simple worksheet. The question on it is, which simple machine would you use to move the elephant? And then circle 1 and explain how you would use to move the elephant. Again, I listed all of them here and a space so that they can write their solution. And so last week I thought of making this class discussion of the worksheet and presenting the problem, and then let each student solve the worksheet on their own. But I would much rather make this into a group activity and let the more advanced students help out their peers with finding the best solution to the problem. During my school observations, I've learned that the gifted and the talented students are able to help out their peers with solving problems because they have a better understanding of the concept, and the other students are able to comprehend more. They're able to learn from their peers as well. So the gifted and talented, they feel that they have a role in the class. They just don't get bored because they already know it and they already understand it, and they feel that they can just finish the work and be the first one to be done, and that's it. So in a group activity and letting the gifted and talented students be the helpers or the mentors, they are able to work in teams, help each other out. So that's what I would much rather do this a group activity. And well, then after the children have finished the worksheet, I would pick them up and I would open the class discussion again and see what each group came up with as in terms of solving the problem with their simple machines knowledge. It's up to you if you want to give them a reward or something for finding the best solution or anything. I don't feel, it's not in my philosophy to reward children for learning, really, but that's up to anybody. And well, that is basically it. Thank you so much for watching. Again, my name is Maria Rincon, and I'll see you next time. Bye-bye.